Welcome to our deep dive, and today we'll be exploring the world of image segmentation. Get ready, because we're about to uncover how computers are learning to see the world, not just in pictures, but in a way that's changing everything from healthcare to how our phones work.
It's an exciting field, that's for sure.
hmm
We're moving beyond simply recognizing what's in an image
hmm
to actually understanding it at a pixel level.
Okay, so before we get too far ahead of ourselves, let's make sure our listener is on the same page. Can you break down exactly what image segmentation is?
Imagine you have a picture of a bustling city street. Image segmentation is like taking that picture and carefully cutting it up into different pieces, each representing a distinct object. Cars, pedestrians, buildings, even the sky.
So it's like solving a jigsaw puzzle, but instead of putting pieces together, we're taking them apart to understand what's in the image.
Exactly. And each piece, or segment,
Mm?
is made up of pixels that share similar characteristics, whether it's color, texture, or even how bright they are.
So it's not just about identifying a car, but understanding exactly where each car is in the picture, down to the pixel level.
That's right. And this is where the different types of image segmentation come in. There's semantic segmentation, which is like giving each pixel a label based on what it represents. Car, road, tree. It gives the computer a basic understanding of the scene.
So it's like teaching a computer the vocabulary of the visual world.
Precisely. But then we have instance segmentation, which takes it a step further. Instead of just car, it identifies each individual car as a separate entity. This is crucial for applications where you need to track multiple objects, like in self-driving cars.
That makes sense. You wouldn't want a self-driving car to just see car up ahead. It needs to know how many cars there are and where each one is to avoid accidents. So how do we actually teach computers to do this segmentation?
There's a whole toolbox of techniques, ranging from simple to incredibly complex. One of the simplest is called thresholding. Imagine adjusting the brightness on a photo until certain objects really stand out.
So kind of like using a filter on Instagram to make a specific color pop.
That's a great analogy. Then there's region growing, which is like coloring within the lines of a coloring book. You start with a pixel and keep adding similar pixels until you've outlined the entire object.
So it's finding all the pixels that belong together based on how they look.
Exactly. Another common technique is K-means clustering. Think about sorting a bag of M&Ms by color. Each cluster of M&Ms represents a different object in the image, based on features like color or texture.
Okay, so we've got thresholding, region growing, and K-means clustering. It sounds like we're giving the computer different strategies to group pixels together and make sense of what's in the image.
That's right. Then there are methods like active contours, often called snakes. Imagine a digital rubber band that can wrap itself around the edges of objects, finding the perfect fit for their boundaries.
It's like the computer is tracing the outline of each object with incredible precision.
You got it. And then there's the real game changer, deep learning.
This is where things get really futuristic.
Right.
I've heard so much about deep learning, but it still feels a bit mysterious.
It's essentially using artificial neural networks, complex systems inspired by the human brain, to teach computers how to segment images with remarkable accuracy. These networks learn by analyzing massive amounts of data, identifying patterns and features that are far too subtle for traditional methods to catch.
So it's like showing the computer millions of pictures
Yeah.
and letting it figure out the rules of how images are structured all on its own.
Exactly. And the results are astounding. Deep learning is revolutionizing image segmentation, opening doors to applications we could only dream of before.
This is where I start to get really excited. What kinds of applications are we talking about? Where is this technology actually being used?
Well, from self-driving cars that can see the road to medical imaging that's changing how we diagnose and treat diseases, image segmentation is already having a huge impact. And the future applications are even more mind-blowing.
I can't wait to hear more. Before we dive into those applications, though, what are some that come to mind for you based on what we've discussed so far?
Let's think about it from the perspective of someone listening. Imagine, for example, having a smartphone that can instantly understand the content of your photos, allowing you to search for specific images without even tagging them. It could revolutionize how we organize and interact with our digital memories.
That would be amazing. Or what about medical diagnoses? If computers can be trained to see abnormalities in medical images, it could help doctors catch diseases earlier and save lives.
Exactly, and these are just a couple of examples. The applications of image segmentation are truly vast, and constantly evolving.
It sounds like we're just scratching the surface of what's possible. I'm ready to dive deeper.
Let's do it. We've got some fascinating examples lined up, starting with the incredible impact this technology is having on healthcare. Welcome back to our deep dive into the world of image segmentation.
We've covered a lot of ground already, learning how computers are being trained to see, like we do, and even starting to imagine how that could change our lives.
It's amazing to think about the potential, isn't it?
Absolutely. I'm especially intrigued by the impact image segmentation is having on healthcare. It feels like we're on the cusp of some major breakthroughs.
You're absolutely right. Image segmentation, especially when paired with the power of deep learning, is changing the game in medicine. Think about it. We can now analyze medical images with incredible precision, spotting tiny details that might be missed by the human eye.
So it's like having a microscopic assistant, helping doctors make diagnoses.
Exactly. Imagine being able to detect the earliest signs of a disease long before any symptoms appear. That's the power of this technology. For example, researchers are using image segmentation to analyze retinal images, the back of the eye, to detect diabetic retinopathy. This condition can lead to blindness, but early detection and treatment can make a huge difference.
It's incredible to think that algorithms can now analyze these images and spot those early warning signs. What other areas of healthcare are being transformed by image segmentation?
It's being used in cardiology to analyze heart images, helping doctors diagnose heart conditions more accurately. In neurology, it's assisting in the analysis of brain scans, potentially aiding in the early detection of conditions like Alzheimer's disease. And in pathology, it's being used to analyze tissue samples, improving the accuracy and speed of diagnoses.
It sounds like image segmentation is becoming an indispensable tool for doctors across a wide range of
It
specialties.
really is. And it's not just about diagnosis, it's also about treatment. Image segmentation can help guide surgeons during complex procedures, providing them with real-time information and improving precision.
That's amazing. So not only can it help detect diseases earlier, but it can also help ensure that treatments are as effective and targeted as possible.
Precisely. And as this technology continues to advance, we can expect even more personalized and effective healthcare solutions.
It's exciting to think about the possibilities, but healthcare is just one area where image segmentation is making waves. I know it's also playing a huge role in the development of robotics.
You're absolutely right. Robotics is another field that's being revolutionized by image segmentation. As robots become more sophisticated, they need to be able to perceive and interact with the world around them, just like humans do.
So it's not just about programming them to perform specific tasks anymore. They need to be able to see and understand their surroundings in real time, to make decisions and adapt to changing situations.
Exactly. Image segmentation is what gives robots that visual intelligence. It allows them to navigate complex environments, identify and manipulate objects, and even collaborate with humans safely and effectively.
I can see how that would be incredibly useful in manufacturing, where robots are already being used to assemble products.
Absolutely. Image segmentation can make those robots even more precise and efficient, improving productivity and quality control. But it goes beyond manufacturing. Think about robots being used in logistics to sort and deliver packages, or in agriculture to harvest crops. Image segmentation allows them to perform these tasks with greater accuracy and speed.
And what about the potential for robots to work alongside humans in healthcare, as we talked about earlier?
That's an area with incredible potential. Imagine surgical robots that can assist surgeons with delicate procedures, improving precision and reducing recovery times. Or think about robots that can help nurses with tasks like lifting and moving patients, freeing up their time for more specialized care.
It sounds like image segmentation is key to creating a future where robots and humans can work together seamlessly and safely.
I believe it is. And this collaboration has the potential to transform not just healthcare, but countless other industries as well.
It's amazing to think about how a technology that started with analyzing pixels in images is now shaping the future of robotics and human-robot interaction.
It is. But the impact of image segmentation goes even beyond those fields. It's also changing how we create and experience art.
Art, that's not something I would have expected. How does image segmentation fit into that world?
Imagine algorithms that can analyze a painting, not just to identify objects, but to understand its composition, brushstrokes, and even the emotions it evokes. This could revolutionize how we understand and appreciate art.
So it's like giving computers the ability to see art through the eyes of an art critic or historian.
Exactly. It's about giving them a deeper understanding of the visual language of art. This could lead to incredible new insights into historical artworks, help identify forgeries, and even guide the restoration of damaged paintings.
It's like giving art conservators and historians a powerful new tool. But what about creating new art? Can image segmentation be used for that?
Absolutely. Think about AI-powered tools that can assist artists in creating new and innovative forms of visual expression. Or imagine algorithms that can generate entire artworks based on a set of parameters or a particular style.
It sounds like a fusion of technology and creativity, opening up entirely new artistic frontiers.
It is. And it's just one more example of how image segmentation is blurring the lines between the digital and physical worlds, changing the way we interact with and experience our surroundings.
It's truly mind-blowing to think about the potential. But with all these advancements, are there any potential downsides we need to be aware of?
That's a great question. Like any powerful technology, image segmentation needs to be developed and used responsibly. We need to ensure that the algorithms are fair and unbiased, and that the technology is not used in ways that could harm individuals or violate privacy.
So it's not just about the technical advancements, but also about the ethical considerations that come with them.
Precisely. We need to have open conversations about the potential risks and benefits of image segmentation, and work together to ensure that it's used for good.
It's a reminder that with great power comes great responsibility. But I have to say, it's incredibly exciting to see how this technology is evolving and the positive impact it's having on so many different fields. From healthcare to robotics to art, image segmentation is truly shaping the world around us.
I couldn't agree more. It's a testament to human ingenuity and our desire to understand and interact with the visual world in new and meaningful ways.
Welcome back to the deep dive. We've been on quite a journey exploring the world of image segmentation, haven't we?
We have. From the basic idea of teaching computers to see to its incredible applications in everything from self-driving cars to art analysis, it's been quite a ride.
It really has. But now that we've covered so much ground, I think it's time to step back and ask the big question. What does all this mean for our listener? Why should they care about image segmentation?
That's a crucial question. At its heart, image segmentation is about more than just technical advancements. It's about bridging the gap between the way humans and machines perceive the world.
So it's not just about making computers smarter, but making them more like us?
In a sense, yes. By teaching computers to understand images at a pixel level, we're giving them the ability to see the world with a level of detail and nuance that was previously unimaginable.
And as they gain this ability, how will it change our lives?
The possibilities are truly vast. Think about personalized medicine, where treatments are tailored to your individual needs based on a deep understanding of your medical scans.
So healthcare becomes truly individualized, not just a one-size-fits-all approach.
Exactly. Or imagine a world where education becomes truly immersive. Students could explore virtual worlds, interact with digital models, and even manipulate historical artifacts, all powered by image segmentation.
Learning becomes so much more engaging and hands-on.
And what about the future of work? We've already talked about robots collaborating with humans in healthcare and manufacturing. But imagine this collaboration extending to countless other industries, from construction to creative fields.
So robots become our partners, not just our replacements, helping us do our jobs better and more efficiently.
Precisely. And let's not forget about the impact on entertainment. Imagine video games and virtual reality experiences that are so realistic and immersive. You truly feel like you've stepped into another world.
It sounds like something out of a science fiction movie.
It does, doesn't it?
Yeah.
But this is the reality we're moving towards, thanks in large part to advancements in image segmentation.
It's mind-blowing to consider all the possibilities, but amidst all this excitement, is there anything we should be cautious about? Any potential downsides to consider?
Absolutely. Like any powerful technology, image segmentation needs to be developed and used responsibly. We need to make sure it's used in ways that benefit humanity as a whole.
So it's not just about the technology itself, but about how we choose to use it.
That's right. We need to have open conversations about the potential risks and benefits and make sure we're using image segmentation in a way that aligns with our values.
It's a good reminder that with great power comes great responsibility. As we wrap up this deep dive, is there one key takeaway you want our listeners to ponder?
Here's something to think about. Image segmentation isn't just a technical advancement, it's a reflection of our own desire to understand the world around us. By teaching machines to see, we're ultimately deepening our own understanding of what it means to perceive and interpret the visual world.
That's beautifully put. It's not just about giving machines new abilities. It's about expanding our own understanding of perception itself.
Exactly. And that's what makes this field so fascinating. It's a journey of discovery, not just for machines, but for humanity as well.
It's been an incredible journey, and I want to thank you for being our expert guide through this fascinating world.
The pleasure was all mine.
Mm.
It's always exciting to explore the potential of image segmentation and imagine the incredible future it holds.
And to our listeners, thank you for joining us on this deep dive into the world of image segmentation. We hope you've gained a new appreciation for this powerful technology and all the ways it's shaping the world around us.
Until next time, keep exploring, keep questioning, and keep seeing the world with fresh eyes.